And also I suggest you to make this tutorial reach a lot of people, because it might be helpful for them in their interview preparations and also for their curriculum, because these questions come up mostly because this is an important topic when it considered to the software programming. If you are not subscribed to our channel, I suggest you to subscribe to our channel and stay tuned to the regular updates we provide on our channel, and try to share them with most of the people if you find them helpful for you. In this vlog, we'll try to see the concept of data structures in software programming. So what is a data structure and why do we need it, and all the details regarding the data structure we'll be trying to cover in this part of this tutorial. And I suggest you to follow this tutorial till the end and don't skip any part of the tutorial, because everything is interlinked and you may get confused if you miss any particular topic. And try to understand each and every topic, because I am going to explain you in a most easy way possible. So now let's get started. So let us try to see what a data structure has. So data structure is of two types, and the first one is like linear data structure and the second one is like non-linear data structure. So from the name itself you can try to understand like the data will be in the form of a linear in the linear data structure, and in the non-linear it will be like in a hierarchical form. So in the coming slides we will try to see with an example like how the data is being stored in linear and non-linear data structures. And also let's try to see few more important aspects before getting started with this particular tutorial. So why do we require data structures? Data structure is an important concept for every software professional. You may be like an experienced professional or a beginner. I suggest you to go through this entire tutorial, because this particular concept is very much useful for you, and even in interviews you will be getting a lot of questions based on this data structure, and you need to also solve few problems based on data structures. Why do we require data structure? Because it solves a lot of problems which you face in a real-time application. So for example, when you try to solve the issues manually, then it might be critical when your app grows into a huge or complex application. Then you need to make use of the best data practices and try to solve these issues. Let's try to see one by one like what is the importance of data structure. So for example, you are having a set of API calls you need to perform in your application. You cannot perform all the API calls at once, and also for some API calls you require the response from the previous API call. So you need to go through a particular flow here like one after the another. So just like our linear data structures, will try to explain like how you can maintain a flow of data, and making this particular arrangement will also make it easier for you to understand the code, like how you are writing the code like one after the another, and how the task is being performed one after the another, avoiding all the confusions when you try to club all the tasks together. So what is the efficiency? So if you try to follow these data structures, you may experience your application working faster than before. So as we have said, we are arranging everything in a flow, so then it takes a lot of time, so it also reduces the time. For example, so if you are having an API calls lined up in splash screen, then it might take a lot of time for the user until all the API calls to get completed, and then he can enter in your application. So you can just divide them and also make these API calls based on the screens where they are required actually, and try to reduce the amount of time the user spends on a single screen. And also you can just store the information for the further use, and all these things adds up to the efficiency of your application. And where we can use data structures, so whatever the programming language it might be, like C, C++, Java, Python, wherever you are trying to make use of this data structure, you will be able to experience the efficiency in the code and also the output you find. I suggest you to get started with data structures only when you have a good knowledge on the programming languages. So here we will try to discuss that point in prerequisites. So before getting started with data structures, I suggest you to have a grip on at least one programming language, because when you have a knowledge of a programming language, then you can easily learn other programming languages because the concept is almost the same. And also data structures mostly depend upon your programming knowledge. So if you are having a good knowledge on how to write a program, for example, you are trying to solve an issue. Let us consider a small issue like you are trying to add two numbers. Then you should also know how to write this particular procedure in a form of a programming language. For example, like in a C program, you need to provide a message to the user like printf, enter the values, and through scanf you need to accept those values and store them into variables, and then adding up and storing the result to a variable and trying to print the result. So here we are thinking in a programmatic way, just not like a simple way like adding 1 plus 1 is 2. We are not going in this way, but we are going in a procedural way. Like, so in this way, data structures, you need to have a programming knowledge to make use of these data structures. So I suggest you to learn any programming language and get started with the data structures. Then it will improve your performance in application as a software developer. Advantages: as we have seen these points, these are the most important advantages like efficiency in reducing the time and increasing the performance. And also you will be able to read through the code easily, and you can understand like if there are multiple developers working on a bit of code or a project, then it will be very helpful for them so that they can get started with data structures and try to understand the concept like how it is implemented in the app level. And just like advantages, every concept will have its own disadvantages. So let us try to understand what's the disadvantage. If you are trying to create a small application, then data structures might sound a bit complex for you, because so for that one or two pages application, then you don't require any data structure. And if you try to add a data structure onto that particular structure of code which you have implemented, then it might take some more time and might be a complicated for even a developer, because even though he don't use any data structure, there might not be any critical issues coming up. So this is a small disadvantage, and also there might be some more disadvantages. And if you find any of them, just and also you can just let me know what are the disadvantages you found using data structures, and also advantages. Let me know in the comment section below, and also your views on the usage of data structure in the application. And also just let me know one more thing, like which programming language you feel easier to get started with data structures, so that the freshers can get started with that particular programming language and gain a more knowledge on data structure and can use the same knowledge onto different programming languages as well. So now let's try to see how the data structure is being categorized into various levels. So now let us try to see what is a linear data structure. So from the name itself, you can see like linear. So the data is arranged in a linear format here. So just like one after the another, here you can see like the best example is again like an array. So in the first box, you are storing some value, and in second box, third box, you can just find out the value based on the index values over here. And in this way, you can just arrange the data here. Other than arrays, there are three more data structures. We'll be discussing more on them in the next slides. And comparatively non-linear data structure, let us try to take an example of a tree here and try to explain. So there is nodes connected here. You can see like child node is connected to the parent node here, and data is being provided in a hierarchical manner, like one after the another here. So from the parent node, you can try to fetch the information to the child nodes, and from the child nodes they can again subdivide it into another two child nodes there. And also the other one is like graph there, and we'll be trying to see more of them in the next slide here. So let us try to see the linear data structures. Again, linear data structure is divided into two types, like static and dynamic here. So what is static here? Just now we have seen an example of array here. So array is a static data structure here. And when we come to dynamic data structure, we do have the three data structures over there. So let us try to discuss one after the another. So under static, we have array, and this is the most basic data structure which most of you might have been experienced using arrays. So based on indexing positions, we will try to make use of these arrays in our applications. So in our coming tutorials we will see in detail on all these topics. So if you are just interested, let me know in the comment section below so that I can create a separate tutorial on each and every data structure with examples. Let's try to see the dynamic data structures now. So the first thing we are trying to cover in the dynamic data structure is like queue. So this queue will follow the first in first out format here. So the first product which enters into the queue will also leave the queue first, and similar to that of we are having stack here, and here the stack is just quite opposite to queue. So the last in first out, so here we follow last in first out flow here. So the product which is added at last to the stack will be removed first. So you can just consider a pile of books one over the another, and if you want to remove the books again back to their positions, you need to again start removing the books from top level itself, right? So this is the best example for stack here. And for the queue, generally you try to observe queues everywhere where you go into the shopping malls or different places. You find queues where people standing in the line to get some tickets, or so that is the best example for the queue here. And the third data structure here is like linked list. So linked list will be having nodes here, so it will be pointing towards the next available node. So here again we do have like two categories here, single linked list and double linked list. And for the single linked list we only go in the forward way, like we have data and the link to the next node, and the next node will be having the data and the link to the next node. So likewise until the nodes are being completed, so that final node will be having a null as a link. And in the double linked list we again have two links here. So on the left hand side and right hand side we have two links, and the first link that is on the left hand side will point to the previous node, and the right hand side will point to the next node, and the data will be in between. So in this way we can implement two ways of linked list, like single and double linked list. And also we do have operations in all these data structures here, like array, queue, stack, linked list. We can add the elements, we can remove the elements, we can perform a search. And when you compare the searching operation here, array is compared to be a faster than all these things, because array is having a fixed size. So that is also a disadvantage of array, because you cannot have more products into an array. If you have specified 10 as a size for an array, so you cannot have more than 10 products into that array. So this is also a disadvantage, like memory constraint. So if you have declared 10 for an array and you are using one or two out of the available total 10 here, so the remaining 8 values will be wasted. And when it comes to the linked list here, then it is sort of a dynamic, not only linked list, stack and queue. So these are the dynamic data structures where these memory issues can be avoided, and also you can add the products as you require and also can remove them easily. So now let's try to see the non-linear data structures here. And non-linear data structures mainly constitute of a tree and graph here. So first let us try to see tree here. In the previous slide we have seen an example like parent node and child node, right? So that is the best example of a tree here, and you can represent the data in the form of hierarchical manner here. And when you consider like a graph here, so here the nodes are connected with the edges here. So with the help of edges these nodes are getting connected. So we make use of this nonlinear data structures to represent the complex scenarios, whereas the linear data structures we can just simply make use of a linear based scenarios where we have one after the another. But here, so when you compare non-linear to linear here, linear will have arrangement of data in a linear way, that is like one after the another, and in the non-linear data structure it will be in a hierarchical manner. So just like we have seen in an example. So in the coming tutorials we will try to see in depth like what is a tree and what is a graph, and also some examples over there, so that you can better understand it. And now let's try to see the final view of a data structure here, which we have seen throughout this tutorial, like data structure classified into linear and non-linear data structure. And again linear is classified to static, dynamic, and static is been like arrays here, and dynamic like queue, stack, linked list here. And linked list is again subdivided into single linked list and double linked list, but the concept is same over there, so I have not provided a separate classification again. only you will be having two links in the double linked list and a single link in the single linked list, so the name stays the same over there. And in a non-linear data structure you have like tree and graph, and you will be using these non-linear data structures in a complex scenarios, and linear data structures you'll be using in a scenarios where like you want to have the data in a linear way, like one after the another. When you consider like graphs here, they might be like the edges are connected with the nodes are connected by their edges, and also they might be like unidirection, or they can be like two-way directed, like you can reach from first node to second node and from second node to first node. So both the things might be possible here in a graph. So this is it for this tutorial on the introduction to data structures. Hope you understood this concept and like this tutorial. Just let me know in the comment section below if I have missed any concept in this particular data structure, or you want to add any new points to this particular tutorial so that the freshers might get benefited. And also I suggest you to make this tutorial reach a lot of people, because it might be helpful for them in their interview preparations and also for their curriculum, because these questions come up mostly because this is an important topic when it considered to the software programming. If you have not subscribed to our channel, I suggest you to subscribe to our channel and stay tuned to the regular updates we provide on our channel, and try to share them with most of the people if you find them helpful for you. Do like, share and subscribe to our channel for more interesting content.